You have an indices problem, and in these type of problems, try to simplify your approach, because otherwise you would be dealing with a lot of solution, a lot of calculations and stuff. You might make a mistake also. Not only that time is a factor, you can make a mistake also. So better to do it in a smart way. So what I'm observing is something like this. So from the first equation to the second equation, I hope you can see the power of x is reducing by 2 and the power of y is increasing by 2, right? So if I divide it, then I'll get in terms of y square and x square, right? So now it matters which one I'm dividing by which one. So I can divide the first equation by the second equation, or the second equation by the first equation. Now, any which way I divide, you'll have one of y or x in the numerator and the other on the denominator. But I mean, just to make the calculation a little bit simpler, so what I'm going to do is I'm trying to keep the the constant term straight away integral, so that I don't want a fraction on that side, because anyhow I'm going to have a fraction in terms of y and x. So I'm going to divide the second equation by the first equation. So if I divide the second equation by first equation, let me write that step elaborately. So you should be able to do this mentally, but let me just do this once for you. So you have something like this. Right. So I hope you can see now that this goes off and you have y square here, and this goes off and you have x square below, right? And we are dividing 8 by half in that case, right? So 8 is in the second equation, half is in the first equation. So this is nothing but 16. So what we essentially have is y square by x square is equal to 16. Right. So since y square by x square is equal to 16, again, we can use this to solve and get our answer. We can, raise both sides by 1008, and in that case, I'll get x to the power 2016 in the denominator, multiplied with 2. Then you get the value of y. Once you get that, substitute, you get the value of x. But that case you might make a mistake actually. I mean, if you do that, then do it with powers of 2. It will be easy to do. You can just write here 2 to the power 4 and then raise it. Also write 2 cube here, then multiply. So in terms, I mean, you will find the value of y in that case if you do that. I mean, raise both the sides by 1008. So you'll have 2016 as a power of x, then multiply, the x goes off. So you'll have the value of y. But as I said, I mean, there's a chance that you make a calculation error if you do it in that way. So instead, what I'm going to do is I'm going to play a little bit smart, because I can see in the options here, each of the options has a 1 by 4 here, right? So because each of the options has a 1 by 4, the interesting part out here is this 1 by 4 can come from x square only, right? I mean, not from this y cube. There's a very little chance that in these cases you'll have a irrational value of x and y. So if you do have that, you cannot have this beautiful options in this way. I mean, if one of the part is irrational, the other has to be rational. So there's a it's a very difficult one to get a rational answer in that case. So what I mean by that is, if you notice the denominators 1 by 4, 1 by 4, 1 by 4, 1 by 4, that by 4 cannot come from a perfect cube, right? It can only come from a perfect cube provided you're cubing an irrational number, that is cube root of 4. But then if you get it from square, that is very much feasible, right? So you can take an assumption. So you can start with this assumption that x square is actually 1 by 4. Okay, because we're adding x square plus y cube. So we can take this assumption that x square is 1 by 4, let's say. So suppose x square is 1 by 4. Now here, all I have to do is just figure out this value of y. So if I substitute x square as 1 by 4, so this comes out to be how much, by the way? So y square is 16x square. So 16 into 1 by 4. So which is 4. So y square is 4, right? Now y square is 4, y can be plus minus 2. But minus 2 is not feasible, because if you check this thing here, x to the power 2016. So this part is positive, and this 8 is also positive, right? So obviously this y to the power 2019 must be positive, which implies that y is positive. So this is pretty easy to analyze. You can do it from the other one also. So because x to the power 2016 has an even power, even if x is negative, x to the power 2016 will be definitely positive, right? So provided, I mean, given that 8 is also a positive value, so y to the power 2019 is positive, which implies that y has to be positive because we have an odd power in this case. So irrespective of y, we cannot have positive. So y being positive, y square being 4. So we have y is equal to 2. So this is obtained, right? So now just substitute 2 and check. So you have y cube here. So 2 cube is 8, right? So all you have to do is add these two up. So 8 plus 1 by 4. We are getting a 33 by 4 as one of the options as the answer, right? So additionally, if you want to verify this, that is absolutely fine because we have taken an assumption to begin with. So what you can do is you can substitute this value of x and y in both of it or any one of it, whichever you're feeling comfortable with. So just substitute and check whether we are getting the expression or not. So you can test on either one. So let me test this out. So I'm putting y equal to 2 and I'll put x is equal to half. I'm not going to put x equal to minus half because irrespective of that, x to the power 2018 will have the same value, right? Because the power is even. So I'm just going to substitute that. So we have y to the power 2017. So that is 2 to the power 2017 and into 1 by 2. So it's basically divided by 2 to the power 2018. And this is coming out to be half. So verified. And if you want, you can check the other one also. So you have y to the power 2019, which is 2 to the power 2019 divided by 2 to the power 2016, which is 2 cube. And that is 8. So this is also verified. So if you want, you can additionally verify these two things. It won't take too much of time because we are dealing with powers of 2. There will be a lot of cancellations any which way. So that is it for this question. So if you do it in this way, then it should not take too much of time. If you are, solving this, you can solve this as I mentioned earlier. I've discussed that process in brief as well. So you can actually solve this out. In that case, you have to be a little cautious while you're solving. So that will take some time because if you want to rush that out, there's a high chance that you mess it up. So it's better that try to do it in a smarter way. So that's it for this particular question. I would say roughly 2 minutes for this question. Should take less than 2 minutes if you are analyzing properly. But the last check that I did was actually necessary. When I solved this question on the paper, I did check this out. I mean, this is the exact process that I did. I did not go into that much elaborated details. I mean, few things, for example, this thing, I can resolve this mentally. I'm checking for that, those kind of things. But then these kind of things, I can do it very quickly. So I managed to do it in a minute or less, I guess. But then again, because I'm good with these kind of analysis, so you have to develop that skill. Because MBA is all about analysis and reasoning and stuff. So it's not more about theorems and formulas. So CAT is testing whether you have those skills or not. So try to develop that. It will help you, especially to get an edge over other aspirants in these type of questions. Because ones which are easy, anybody can solve, right? Unless you make a silly mistake. So that's it for this question. You may solve it in round 1 or round 2, up to you. Thank you for joining in.